Hello friends! Continuing with the educational videos on the LS 100 inverter, today we want to talk about the digital outputs of the S100 inverter. Digital outputs like relays and transistor outputs. As you can see in this diagram, the S100 inverter has two digital outputs, the Q1 and EG outputs, which are related to the transistor output of this inverter, and the A1 and B1 outputs, which are related to the relay output of the inverter. If you want to use a normally open relay output, you should use the A1 and C1 terminals, and if you want to use a normally closed relay output, you should use the B1 and C1 terminals. A1 and C1 are normally open in their default state, the contact is open, and B1 and C1 are normally closed. The Q1 and EG outputs are also related to the transistor output of the S100 inverter. Now, the settings that need to be made for the digital outputs of the S100 inverter are as follows. To configure the digital outputs, such as relay and transistor outputs, on the S100 inverter, you need to enter the OU or OUT parameter group. The in group is related to the digital inputs of the S100 inverter. When we wanted to configure or assign values to the digital inputs, we would go to the in group. Now, since we are dealing with digital outputs, as the name suggests, we need to go to the OU or OUT parameter group. The OUSC01 parameter, as you can see here, is related to relay 1 of the inverter, which is the same as A1C1 or B1C1. OUSC02 is related to relay 2. In the schematic we had in the previous slides, there was only one relay. This OSC02, which is for relay 2, is present in S100 inverters with power ratings from 30 kilowatts and above. That is up to 30 kilowatts. The S100 inverter has one relay output, and from 30 to 75 kilowatts, it has two relay outputs. So if your inverter is from 0.37 kilowatts up to 30 kilowatts, you can configure relay 1 in the OUSC01 parameter. And if your inverter is above 30 kilowatts, you can also assign a function to relay 2 in OUSC02 and set its value. To define the value for Q1, which is the transistor output, you need to go to the OUSC03 parameter. So OUSC01 is for defining relay 1, OUSC02 is for relay 2, and OUSC03 is for the transistor output or the Q1 terminal. In this example, in this training video, we want to use the digital outputs of the S100 inverter. We said that if we want to use relay 1 of this inverter, we need to go to the OUSC01 parameter. And if we want to use the transistor output, we need to go to the OUSC03 parameter. If you want relay 1 of the inverter to be activated as soon as the inverter runs, you should set the OUS31 parameter to 14. If we set the OUS31 parameter to 14, relay 1 of the inverter will be defined on run, meaning as soon as your inverter runs, relay 1 will be activated. That is, the A1C1 contact will close or the B1C1 contact will open. If you want the transistor output of the inverter to be activated as soon as the inverter stops, you should set the OU33 parameter to 15. So if we want a relay in the S100 inverter to be activated as soon as it runs, we should set it to 14. If we want either the transistor output or the relay output to be activated as soon as the inverter stops or after it stops, we should set it to 15. Here we want relay 1 to be activated as soon as it runs and our transistor output to be activated after it stops. So we should set the parameter on OUS31 to 14, meaning relay 1 will be activated on run, and for the transistor output, we set its parameter OUS33 to 15 so that the transistor output is activated after stopping. Now what will our wiring look like? Here, we want to use one transistor output and one relay output from the S100 inverter. For example, for the stop state, we want to use the transistor output, and for the run state, we want to use the relay output. I want to configure the relay output so that it activates as soon as the inverter runs and the transistor output activates after stopping. The way we do this is by supplying 24 volts to one side of our signal lamp. then connecting the other side of the signal lamp to the Q1 terminal of the inverter, which is the transistor output, and connecting the common terminal of the transistor output, e.g., to the CM terminal of the inverter. If we wire it this way, our signal lamp will turn on after the inverter stops. As for the relay output, you can use either 24 volts DC or 220 volts AC, depending on your signal lamp. We supply either 220 volts or 24 volts DC to our signal lamp. Connect the other side of the signal lamp to the X1 terminal and connect the common terminal C1 to the CM terminal. You could also use the B1C1 terminals, which would be the normally closed contact, but we used X1C1, meaning as soon as the inverter runs, this contact closes, relay 1 is activated, and our signal lamp turns on. So what we want to do in this training video is to have our relay output activate as soon as the inverter runs and turn on the signal lamp, and have our transistor output activate after stopping and turn on the signal lamp. Let's go through all the settings we've learned so far and test the digital outputs of the S100 inverter together. To configure the digital outputs of the S100 inverter, as we said, we need to go to the OU parameter group. In the OU parameter group, OUSCO1 is for relay 1. We want relay 1 to turn on as soon as the inverter runs, so we enter this parameter and set it to 14. So when you set OSCO1 to 14, relay 1 will activate as soon as the inverter runs. Now we want the transistor output Q1 to activate after the inverter stops, meaning whenever the inverter is in the stop state, the transistor output should operate. As we said, we need to go to the OUS33 parameter for the transistor output and set it to 15. Now you can see that my inverter is in the stop state and hasn't run yet, so my transistor output should be active. You can see that the signal lamp is on. Now if I start my inverter, the signal lamp related to the relay output should activate. I start the inverter and you can see that the signal lamp for the stop state turns off, meaning the transistor output deactivates and the relay output activates. Now if I stop the inverter, the relay output deactivates, and after stopping, the transistor output activates. Now the inverter is stopped and you can see that the signal lamp related to the transistor output, which was set for the stop state, is activated. I'll start the inverter again, my relay output is activated. I stop it again, the relay output deactivates and the transistor output, which is set for the stop state, is activated. So in this video we learned how to configure the digital outputs of the S100 inverter, both the relay and transistor outputs, and how to assign their functions and activate them in different states.